Good evening. Welcome to the ISC 12 Maths tutorial. Today's topic is derivatives part 2. Today we are going to learn how to find out the derivatives of implicit functions and logarithmic functions. In part 1, in my previous lecture, we learned how to find out the derivatives of logarithmic functions. Today we will see some more examples of logarithmic functions and implicit functions also. Today we will be discussing. The first question we are taking is 2x plus 3y is equal to sin x. We have to find out dy upon dx. Okay, let's start. This is the question, 2x plus 3y is equal to sin x, to find dy upon dx. Okay, now we start. Once again we write this, we call it equation number 1. And then as usual we write, on differentiating both sides with respect to x we get. On differentiating both sides with respect to x we get. What we get? Let's write down. We get 2 ddx of x plus 3 ddx of y. So we are writing dy upon dx. Dy upon dx is equal to dx of sin x. Alright, only I have written down the operator ddx, differential coefficient with respect to x of x, differential coefficient with respect to x of y, that is dy upon dx, and differential coefficient with respect to x of sin x. Alright. Now, next step. ddx of x is 1, you know. So 2 into 1 is 2 directly, we can write down 2. Is that fine? So 2 into 1. So 2 into 1 is 2 directly. Plus 3 dy upon dx. Is equal to ddx of sin x. ddx of sin x, very simple basic formula. I have given you a set of formulas. 20 formulas I have given you. So ddx of sin x is cos x. You see the formula, that sheet. ddx of sin x is cos x. So cos x. ddx of sin x is cos x. Alright, next. Two, we transpose from left to the right side and we write 3 dy upon dx. 3 dy upon dx is equal to cos x and minus 2. And then 3 we take down. So therefore dy upon dx. Therefore dy upon dx is equal to 1 upon 3 cos x minus 2, and this is answer. This is the answer. Alright, so dy upon dx is equal to 1 upon 3 cos x minus 2 is the answer. Hope it is clear. Now question number 2. Question number 2. The question is, please write down the question. If x plus y whole square is equal to 2axy, x plus y whole square Question number 2. If x plus y whole square is equal to x plus y whole square is equal to how much? 2axy. 2axy. Then find dy upon dx. Find dy upon dx as usual. Alright. So, we can call this equation number 1. As usual, on differentiating both sides with respect to x, we get, you write down please here, on differentiating both sides with respect to x, we get d dx. On both the sides I am writing d dx, d dx. d dx of x plus y whole square. Alright. d dx of x plus y whole square is equal to d dx of 2axy. Only I am writing d dx on both the sides, nothing I have done in this step. Please try to understand. See this, d dx, d dx. Okay. Now in the next step, this we will treat as x raised to the power n, this total. Alright. This full total, x raised to the power n, and we will apply the formula. We have the formula d dx of x raised to the power n is equal to n and n x raised to the power n minus 1. And because this is not x plus y, so once again we differentiate it. Alright. And here d dx of c fx, that is the formula, d dx of c fx. C is a constant, here 2a is a constant. So c will come out, c f dash x means d dx of fx. So here 2a will come out and we write down 2a d dx of xy. Alright. So next step we write n x raised to the power n minus 1, x raised to the power n minus, this whole thing we are treating as this we are treating as x, this we are taking as x. So x raised to the power n is n, x raised to the power n minus 1. 2 minus 1 is 1, which we don't write directly, at least that much you understand. Alright. But this is not x, so once again we differentiate it. So into d dx of x plus y. Alright. And the right side is 2a outside and d dx of xy. Let me write down once d dx of xy. d dx of xy. Alright. Now here it is the product of two functions uv. uv. You know the formula uv, that also I have given you, d dx of uv, u, d dx of v, plus v, d dx of u. In other words, first function into derivative of second function plus second function into derivative of first function. That formula we will apply. See, this also I have given you. Alright. So, this we can write down then 2 and x plus y d dx of x plus y. So d dx of x plus d dx of y. There is another formula I have given you, d dx of u plus v. Please see, d dx of u plus v is equal to d dx of u plus d dx of v. Alright. So if you follow that formula, we write down If we use that formula, we write down dx of x plus, can I write down directly ddx of x as 1? Please allow me to write down. Huh? So directly I am writing ddx of x as 1. So this will become 1 plus ddx of x is 1 and then plus, and this will become dy upon dx. Is this fine? This is left hand side. Right hand side is 2a as it is. Now product of the function. Product of the function means first function into derivative of second plus second function into derivative of first, means x. Say first function into derivative of second plus second into derivative of first. ddx of x is 1, so that we don't write. I don't write. Is that fine? Understood? So you are here. Got it? Now 2 and 2 we can cancel. 2 cancels 2. This 2 cancels this 2. Is that okay? And then we get, can I delete this? And now the remaining terms, so now see the changes that how I am writing. How am I writing? X plus y into 1 is x plus y. I just want to collect all the terms with dy upon dx. So here there is dy upon dx multiplied by x plus y, and here there is dy upon dx multiplied by ax. Alright. So if I bring this to the left hand side, and here already there is dy upon dx, so x plus 1 into dy upon dx minus ax dy upon dx. So can I take dy upon dx common? Do you understand? So if you agree with that, dy upon dx I will take common. I am doing two things. One, I am transposing this ax dy upon dx from right hand side to the left hand side and taking dy upon dx common. Okay, so we get x plus y. We get x plus y minus x and dy upon dx. Dy upon dx, okay, and then that side we get, see, ay right side, and on the left hand side we have x plus y into 1, means x plus y. So this x plus y we take from left hand side to the right hand side, that will become minus x minus y. Alright, so minus x minus y minus x minus y plus ay. Alright, and if we take minus outside common, if we take outside common, then inside we will get x plus y minus ay. If you agree, please say this. You can do the rough calculation on a piece of paper. Paper and pen you should have with you. If certain things you don't understand, you please do the calculation, do the rough work. Ay plus, and this comes to the right hand side, minus x minus y. Minus we are taking common. So this becomes x plus y, and this plus ay will become minus ay because minus we have taken common. Is that okay? Therefore dy upon dx, now we got the result. Therefore dy upon dx is equal to. Therefore dy upon dx is equal to minus, we may write down minus here, let this be minus. Okay, this is minus. So minus x plus y minus ay whole divided by x plus y minus x. x plus y minus x. This is the answer. Let me check. So your answer is minus x plus y minus ay upon x plus y minus x. Yes, correct answer. The answer is correct. This is your answer. This is your answer. Is that fine? Understood? Now next question. Question number 3. Third question. Question number 3 we are taking. Please write down the question. Right question. Differentiate the following function with respect to x. Differentiate the following function with respect to x. Differentiate the following function with respect to x, and the function is this. This is our third question. The function is let y is equal to. So please write down the question. Once again I am repeating. Write down differentiate the following function with respect to x, and the function is, in the numerator write down 2x plus 1, 2x plus 1, and then 3x minus 1 whole divided by x plus 5. So differentiate the following function with respect to x and write down this function. Okay, this is your question. Now I start solving the question. How will you start? So start. Let y is equal to. No? So we start like this. Let y is equal to. Now the solution starts. That means once again you have to write down. That was the question. Now write down again. Let y is equal to this. Right? Now see, here we will be taking first logarithm. We'll simplify the expression and then we'll differentiate. See, we have product of 4 expressions are there. Here 3 expressions are there. 2 in product, 1 in division. Right. And you know in logarithm we have formulas log m into n is equal to log m plus log n, or log m upon n is equal to log m minus log n. Alright, so if we use those formulae, we get a simplified expression, and very easily a term by term we can differentiate each of the terms. You please have a look, then you will understand why are we applying here logarithm first. First try to understand. So on taking log of both the sides we get, so please write down, on taking log of both the sides we get, here you may write down, on taking log of both the sides we get log y is equal to. Log y is equal to log m into n upon p. Can I write down directly log m plus log n minus log p? At least that means you should understand, because logarithm we have done in 9th standard, ISC 9th standard, in detail we have done logarithm. All those formulas we explained to, of course, we explained to the students in detail. I explain in detail because I know that the things are going to come in the higher classes. Alright. If you are not okay with the basics of logarithm, please go through it. It is given in detail in 9th standard, ICSE 9th standard. Alright, go through all those formulas. Log m into n is equal to log m plus log n. Log m upon n is equal to log m minus log n. Log m raised to the power n is equal to n log m, etc. etc. Alright, so here if we take this as m n p, so log m plus log n, because they are in product. So log m plus log n minus log p. Alright, but before I apply the formula, let me first write down only log on both the sides. Alright, so we are writing log here and log here. Log and the same thing. 2x plus 1, and this is 3x minus 1, and down x plus 5. Alright. Fine, not required, but if you want, you can put a bracket also. So what I have done, I have only written log on both the sides. We have taken logarithm of both the sides. Now we are going to apply the formula of logarithm. As I explained to you, m and p. So log m and p. Log m plus log n minus log p. Alright. So next step. So log y is equal to log this log how much? 2x plus 1. Alright. Log 2x plus 1 plus log 3x minus 1 plus log 3x minus 1 minus log x plus y. Okay, log m plus log n minus log p. Okay. Now we differentiate both, because see, now you have, see what did we get? We got one term separately with plus and minus, and we have the formula log u plus v is ddx of u plus v. So we differentiate separately ddx of u plus ddx of v, or ddx of u plus v plus ddx of u plus v plus p. Maybe you can take more than two functions. So separately we differentiate. Here also we have separate terms. We'll differentiate this independently. We'll differentiate this. We'll differentiate this. Right. Now on differentiating both sides, please write down here now. On differentiating both sides with respect to x, we get. On differentiating both sides with respect to x, we get. What do we get? On differentiating both sides with respect to x, we get. Now we differentiate both the sides. Okay. So after writing this, you will write down. Okay. Can I delete now? But this you have to write down. After this, you will write down. So then you write. After that, you write ddx of log y. Ddx of log y is equal to ddx of log 2x plus 1. Ddx of log 3x minus 1 plus 3x minus 1 and minus ddx of log x plus 5 minus ddx of log x plus 5. Is that okay? Nothing we have done. Nothing I have done, only ddx I have written down everywhere because we are differentiating with respect to x. But see, ddx. One more thing very important, just please try to understand here. This will help you even in the when we go ahead. When we move ahead with the when we solve difficult questions on derivatives. See, ddx of log y. This function is in y, and we are going to differentiate with respect to x, which is not possible. We cannot do that. If the function is in y, we have to differentiate with respect to y. If the function is in x, we have to differentiate with respect to x. So here it's okay. Here the function is in x, log 2x plus 1. Alright? Log 2x plus 1, please understand. Try to understand. Alright? So log 2x plus 1, the function is in x, we can differentiate with respect to x. The function is in x, we can differentiate with respect to x. And the same thing is applicable here, but here not, because here the function is in y. The function is in y, and we are going to differentiate with respect to x, which is not possible. So some change, a small change we will make. Just have a look, see. What am I going to do? So I lie down, because we want it. So what we want, we'll do it. And then after that, we will try to make it up. So dy of log y. Alright, so we write down dy of log y. Please see this change into dy upon dx. See this is the same thing. See this, dy and dy. For some time, for understanding point of view, please consider that. See that dy and dy cancels each other, and then ultimately we are left with dx of log y. So dx of log y. Alright, we are writing dy in the denominator and we are writing dy in the numerator. We are multiplying numerator by dy, we are dividing numerator by dy by the same number, which is not the concept, but only to make you understand. For understanding point of view, I'm just telling you. You multiply by dy upon dy, you divide by dy. Alright, and write like this, dy of log y to dy upon dx. That means this and this, they are same. Alright, but it's not the meaning, that's not the concept. Alright. Now log y, function in y with respect to y, we can differentiate. It is like ddx of log x, same formula, dy of log y. So ddx of log x is 1 upon x. Ddy of log y will be 1 upon y, not x, y. Ddx of log x is 1 upon x. So dy of log y is 1 upon y and dy upon dx. And this is what we want. We want dy upon dx. That is the question. Is that fine? And this side, if you want, I can differentiate. Ddx of log x is 1 upon x. So 1 upon x. 1 upon 2x plus 1. And once again you differentiate this whole thing, because this is not x. So when we differentiate 2x plus 1, so that means we differentiate 2x plus we differentiate 1. So 2x when we differentiate, 2 we keep aside and derivative of x will be 1. So 2 into 1 is 2, directly 2, and derivative of 1 is 0. So 0 we are not going to write down because it is with plus sign. Plus 0 means nothing. So can I write down directly 2 then? Because 2 into ddx of x, which is 1. So 2 into 1 is 2, and this 0. So 2 into 2 plus ddx of log x is 1 upon x again. And when we differentiate, ddx of 3x minus ddx of 1. So ddx of 3x will give you 3 into ddx of x, and ddx of x is 1. So 3 and minus 0. So only 3. Only 3. Minus 1 upon x plus 5. ddx of log x, 1 upon x means 1 upon x plus 5. And when you differentiate this again, ddx of x will be 1 and that of 5 will be 0. So 1 means nothing. So 1 upon x plus 5 plus minus 1 upon x plus 5. Alright, clear? Now look here, dy of log y is 1 upon y. So we write 1 upon y into dy upon dx is equal to 2 upon 2x plus 1 plus 3 upon 3x minus 1 minus 1 upon x plus 5. Is this okay? 2 ones are 2, 3 ones are 3. That's it. Now this y will come this side. So dy upon dx is equal to y into this. And the value of y, the original value of y, which was this into this upon this, that we'll write down. So therefore dy upon dx is equal to. Can we go ahead? Okay. Therefore dy upon dx is equal to. Therefore dy upon dx is equal to y, and this whole thing 2 upon 2x plus 1. Upon 2x plus 1 plus 3 upon 3x minus 1 upon x plus 5. Alright, we got this. Now the value of y will write down and we get the result. That will be the answer. That will be the answer, y. So the only thing is you write down the value of y. So this is equal to the value of y, write down 2x plus 1, 3x minus 1 upon x plus 5, this is y, and in bracket the whole thing, this whole thing, 2 upon plus 3 upon minus 1 upon, so 2 upon 2x plus 1. Three x minus 1 and x plus 5. Alright, so dy upon dx is equal to this much. This is the answer. Alright. Hope it is very, very clear. This was the third question. Now the fourth question is little different. So let's see that. Question number 4. Please write down the question. And you know, these questions I am taking from the sheet that I have already given you. You remember I gave you a sheet where there were 15 questions. So these are the questions from that sheet only. This last question, fourth question that I am going to do, this is your 15th question, question number 15 from your sheet that I have given you. Right. So write down. Question, write down please. Here also we'll apply, this is also logarithmic function. Differentiate, write down. Fourth question. Differentiate the following function with respect to x. And the function is, write down, x raised to the power x plus sin x raised to the power x. X raised to the power x plus sin x raised to the power x. This is our function and we have to differentiate this with respect to x. Alright. So I hope you wrote down the question. Alright. Now x raised to the power x plus sin x whole raised to the power x. Yes. Now we start like this. Let y is equal to. Let y is equal to this. Alright. Can we take logarithm on both the sides in this present form? Sometimes the students do this. They take the logarithm of both the sides and what they write down log y is equal to x log x plus x log sin x, which is wrong. You are writing plus. Plus you will write down when they are in product. Log m into n is equal to log m plus log n. Agree? Please understand. You cannot write down if suppose you have log mn is equal to log m plus log n. Alright, log mn is equal to log m plus log n. Things will be clear. Please wait. Let's go ahead. So y is equal to this. We cannot take logarithm in this present form. We cannot write down log y is equal to x log x plus x log sin x. Plus we are writing no in the middle, and that will happen only if this is in multiplication product. Alright. So what we do, we differentiate them separately. Suppose this is u. We are taking this as u. Suppose this is u and this is v. Alright. And y, of course, we have taken y. So y is equal to u plus v. U is this function and v is this function. Now two different questions. You can take two questions separately. So where one function is x raised to the power x, you have to differentiate it. Differentiate it as you saw. You take log and then differentiate, and finally you get du upon dx. Similarly, you differentiate this separately. V is this, then take log. I'll show you. We are going to do it. Alright. Once we, because see, we want dy upon dx, no? Therefore dy upon dx and therefore dy upon dx is equal to dy upon dx is equal to how much? Du upon dx plus dv upon dx. Okay. dy upon dx is equal to du upon dx plus dv upon dx. Right? We find out du upon dx and dv upon dx separately, and then we substitute here. So we can call this equation number 1, where finally we are going to substitute the values of because we want dy upon dx. We want the differential coefficient of this entire thing which we are taking as y. This full thing, differential coefficient of this function means dy upon dx. So dy upon dx, which is du upon dx plus dv upon dx. Alright, so let's start one by one. When u is equal to x raised to the power x. Right? So u is equal to x raised to the power x. U is equal to x raised to the power x. U is equal to x raised to the power x. Take log of both the sides because it's not x raised to the power n. This is alright. It's not x raised to the power n. You have to take log. So log u is equal to, on taking log of both the sides, we get log u is equal to now let me write down directly, because now the question is big, then the steps are more. So I can't show you all the small steps here. So log u is equal to log of this, and this x will come out. Log m raised to the power n is equal to n log m. So we can write down x log, if you agree. Can we write down this? X log x. Now we differentiate. On differentiating both sides with respect to x, we get. On differentiating both sides with respect to x, we get. So we get, you have to write down here, right? On differentiating both sides with respect to x, we get. So we get ddx of log u is equal to ddx of x log x. X log x. Alright, this is one function. X log x. Actually, we are doing two separate questions. Now, one function is this, and second we'll take, first we find out the du upon dx, and then we'll take sin x raised to the power x, and we'll find out dv upon dx. Right? Not difficult. Only you have to understand that you cannot take logarithm in the beginning only. Okay, then next. Now, in just now I told you that if the function is in u, we have to differentiate that with respect to u. So we'll write down d du of log u into du upon dx. Alright, and d du of log u will be 1 upon u. So 1 upon u du upon dx. If you understand, please allow me to write down. So 1 upon u du upon dx. 1 upon u du upon dx is equal to here product of the function. Product formula u. This you can take as u and this we can take as v. Alright. uv. First function derivative of second plus second function derivative of first. So first function x and ddx of log x. Chalo, I am writing for you. Log x plus log x and ddx of x. ddx of x, product formula. You please write down your formula. You should write down. You should write down formula here. Right? ddx of uv is equal to u. ddx of u equal to u ddx of v plus v ddx of u. Alright. Now, then we get, which formula are you going to write down here? You will write down the formula, but I am just giving the left hand side. d dx of uv. Alright. Now this gives you x and ddx of log x is again 1 upon x. ddx of log x 1 upon x plus log x. And ddx of x is 1. 1 in product multiplication. It doesn't affect log x. Fine. Is it fine? Now this x and x cancels each other and we get 1. So in the next step we write down 1 plus log x. In the next step we write down 1 plus log x. We got 1 plus log x. This du upon dx, 1 upon u, du upon dx. So therefore du upon dx, u will go to that side. So therefore du upon dx is equal to u 1 plus log x. Can I delete? Therefore du upon dx is equal to u and 1 plus log x. What do you say? Okay? 1 plus log x. Du upon dx is equal to u 1 plus log x. This is x. No confusion. X. Now let's write down the value of u. What is the value of u? Is this? Is this? Fine. So x raised to power x 1 plus log x we are getting. We get that. This is du upon dx. We can call this equation number 2. Du upon dx, we can call this equation number 2. We are going to use it. Du upon dx. Right? Again, now v is equal to how much? Again v is equal to. Can I delete it? Again v is equal to. One part is done. Now again v is equal to. So v is equal to sin x raised to the power x. Sin x raised to the power x. V is equal to, again v is equal to v is equal to sin x raised to the power x. Alright. Therefore we are taking log of both the sides. Therefore log v is equal to x log sin x. Can I write down directly? Log m raised to the power n, so n log n. Right, so x log sin x. X log sin, you write down, but when you solve, please write down. Once you write down log on both the sides, alright. Once you write down, like you write down log v. Let me show you. Log v is equal to log sin x raised to the power x, like this. You're only writing log on both the sides. And now log m raised to the power n. Log m raised to the power n is n log m. Basic formula from ISC 9 standard, class 9. Right. Now we differentiate. On differentiating, as usual, on differentiating both sides with respect to, so please write down here. On differentiating both sides with respect to on differentiating both sides with respect to x, we get d dx on both the sides. So therefore d dx, only few more steps, we are getting rid of that. So therefore d dx of log v is equal to d dx of x log sin x. X log sin x. Now product again, and here as you know, now I think you are okay with it. If I write down directly 1 upon v dv upon dx, because we have to write down d dv of log v into dv upon dx. So please do practice. So 1 upon v dv upon dx we can write down. Therefore 1 upon v dv upon dx is equal to product of the function u, and this total is v. This is one function, log sin x. First function into derivative of second, d dx of log sin x. d dx of log sin x plus log sin x into d dx of x into d dx of x into d dx of x. Alright? First function derivative of second plus second function derivative of first. And therefore, so we get then this is equal to x and d dx of log x, log sin x, this we consider as x. So d dx of log x is 1 upon x. But this is not x, this is sin x, so we again differentiate sin x. d dx of sin, I am writing directly. You please show these steps when you write. So into d dx of sin x, or should I write down? Okay, I am writing. So d dx of log x is 1 upon x into d dx of sin x into d dx of sin x. Alright. and plus into d dx of sin x. Alright, and here log sin x, d dx of x is 1, so plus log sin x. Plus log sin x. Okay, and that is equal to, so therefore 1 upon v dv upon dx is equal to, d dx of sin x is cos x, x cos x upon sin x, plus log sin x. Plus log sin, you can put a bracket if you want. Right. And this is equal to x cot x, cos upon sin is cot, plus log sin x. This is 1 upon v dv upon dx. Therefore dv upon dx, we will come to this side. Therefore dv upon dx is equal. Therefore dv upon dx is equal to v, and then this whole thing, x cot x plus log sin x. X cot x plus log sin x. Alright. This is fine. Now 2-3 more steps. dv upon dx we got. And then we write down the value of v. The value of v is sin x raised to the power x. So sin x raised to the power x, and this bracket also you can use, so x cot x plus log sin x. This is your dv upon dx. Now du upon dx and dv upon dx, this is equation number 3. Now from 2 and 3, the values of, from 2 the value of du upon dx, and from 3 the value of dv upon dx, that to substitute in equation number 1, where you have written, please see, where you have written, you should note it down, where you have written dy upon dx is equal to du upon dx plus dv upon dx. Alright, so from 1, therefore from 1, therefore from 1, therefore from 1, 2 and 3 you can say. Therefore from 1, 2 and 3. From 1, 2 and 3 we get, what do we get? dy upon dx is equal to, you have du upon dx plus dv upon dx. Alright. Now, okay, now let's substitute the values of du upon dx and dv upon dx. So, dv upon dx, let me use this only. This is dv upon dx and is equal to, and what is du upon dx? X raised to the power x. Du upon dx is x raised to the power x. Whatever the value of du upon dx you got, that value you write down here, plus, this is plus. Alright, and here you write down the value of du upon dx. copy from there, du upon dx. X raised to the power x and log 1 plus x, I guess. X raised to the power x log 1 plus x. Alright, so that will be answer, du upon dx. Just let me see. Just 1 minute. Yeah, x, I think it is x raised to the power x 1 plus log x. 1 plus log x. So this is, let me write down the value. I am writing down the value. The value of du upon dx, I guess it is x raised to the power x and 1 plus log x. This is du upon dx and this is dv upon dx, and this total is dy upon dx. So dy upon dx is equal to this, and this is the answer, big answer. Alright, okay, hope things are clear. Please check it. This value is the value of du upon dx. So please check it, because that du upon dx we have got in equation number 2. Alright, okay then, thank you so much. Thanks.